So the first part is asking you a question, and then the second part is going to be an open-ended question. All right, here we go with the meter. I haven't even taken roll yet. Let's see. All right. Copy. 8 days. Paste. All right. I had to do a new attendance. All right, I'm going to try to run through this really quick and see if I see everyone. Wow. I would like, if you can, I would like for everybody to vote on this so I can just know, because I want to set up the classroom. You know, I don't need to put out 35,000 chairs if half of you guys aren't coming back. All right, let me see who I got here today. All right, so today is the 7th. I think I saw. All right, if you guys can do me a favor, I'm just gonna go through row really quick. It's gonna take me too long to go through the list. Some of you guys I saw, but I'm just gonna go down really quickly. So Lamar, if you're here, just unmute. Don't put it in the chat. Unmute and tell me you're here. So I didn't see Lamar. I think I saw Alexa. I did not see Essence. I saw Sam, saw Jasmine, saw Kanye, saw Charles, Serena, Isaac, Gabby. Natalia, are you here?
Yes.
Okay. I don't think I saw Maria. I think I saw Brandon, Muhammad, Stephanie. Jessica, are you here? Okay. Daniela, are you here?
Yes.
Okay. I saw Josh, Kaya. Elmer, are you here? I saw Cam. Sage and Michael, are you guys here? Okay. So no Lamar, no Essence, no Maria, no Jessica, no Elmer, no Sage, no Michael. All right, here's the second part of the Mentimeter. Wow, only 4 people who know for sure they're coming back. Okay. All right, here is the second part of the Mentimeter. You should be able to, it should have just populated on your screen. If not, you can click the link from the chat again. So this just, do you have any reservations about coming up to school? Which is ironic because today's School with You is not working. Or if you're gonna be, because right now it looks like it's gonna be, I'm gonna have to teach both of you at the same time. It's gonna be interesting. Very interesting. So, oh, sorry, Elmer, okay. All right, so that's this thing. That's a good question. I have no idea how it's going to be in terms of changing classes. I think I want to say at one point, and this might have been a long time ago, they were saying they were going to change by hallway, but I could be wrong. Yeah, that's a fear for me too. Not a fear that I won't pay attention to you guys, but how to, I'm just being honest. I don't know how I'm going to like, so the teaching part, yes, but it's like if someone has a question, the good thing is if someone has a question and they're here, the people online can hear it. But I don't know if I'm going to have like my board turned. So like, because I don't want people to feel like I got to be on camera because I'm at school. So it should be facing me still. But then like if somebody has a question, am I just going to be like, I'll be back, y'all. And like, you know, just leave the camera. I don't know how that's going to work. Coming to school, being scared of around so many people and also online, it will be hard to learn what you're teaching this. So yeah, that's That's a real concern. And it's gonna be confusing for me too. Ooh, yeah. I mean, and that's my so the kids not taking the proper precautions. That's a fear for me too as a teacher, right? Like I don't want to go home every day and have to quarantine. Like I want to be able to hang out with my family. I don't want to be like, oh well, you know, these 5 kids decided in class they didn't want to wear their mask, and now when I go home, I need to make sure I be in a room all by myself. Um, I'm staying home, so I'm mostly concerned about waking up early and just sitting there. Didn't even think about that because you guys are now used to, I assume, waking up at 8:30, 8:45, maybe 8 o'clock. Some people may wake up early, but also a very, yeah. I'm gonna save all these responses because these are good questions. Hi, yes, I saw you come in. Sorry. Can you unmute and tell me how to pronounce your name? Is it Aris or Eris?
It's Eris.
Eris. Okay. Yes, I have you down. I saw you.
Oh, thank you.
There is. So if you have, so we just really kind of started a new unit yesterday, Eris. I'll tell you what we did, but then if you'll just
Hmm.
take notes today, you'll be fine. We're
Oh,
starting
okay.
a brand new unit.
Okay.
Okay. All right. So these are really good concerns, guys. I'm gonna screenshot this and save it and try to get some of these answers for you, like how's it gonna be when we switch classes? And um, they said they're gonna take pretty seriously people making sure they keep their mask on and stuff. And then I'll try to get some more stuff about how you know, they did send an email and it's like some teachers are like in tripods and all this other stuff so they can like teach here and there. Um, the only, I'll put it this way, the only thing I ask is that you guys, if whether you're in the classroom or you're online, if you feel like you are being shortchanged in some way, like I'm not paying you guys enough attention, just tell me. Like I don't want to shortchange anybody, so you can just send me a message on Remind. Oh, Eris, I need to get you signed up for Remind. Um, uh, Whatever, just tell me, guys. Just tell me. Say, hey, Miss Payne, I don't feel like you paying attention to this. Just let me know, because sometimes I wouldn't do it intentionally. So just let me know. All right. Okay, so today we are taking notes. I'm going to stand up and teach today. It'll be my first time since March standing up and teaching. I'm kind of excited. Uh, I'm just going to pretend. I should have put like little stick people in my chairs and pretending that you guys were all here. I'm probably going to just turn my computer this way. So I'm going to be teaching from this board so you guys can kind of see what I'll be doing. But I'm going to share that screen anyway. I'm going to turn it so I can see it, but I'm going to share that screen because I'm going to be writing on there. And if I only called the names of the people who I did not see. So if I didn't call your name, I know you are here. So, all right. So I'm going to stop sharing. Hopefully you did your video notes. So today we're going to talk about, we're going to do a couple definitions. And then I was going to give you a quiz today, but I think I'm going to try to push through some of the material. And then when I say quiz, I mean a homework quiz. So homework. But I think I'm going to push through and we'll just do it on Monday. So today we're going to talk about, just make sure we understand states of matter, which I know you guys know those, but I'm going to show you some drawings. And then physical chemical changes, I want to make sure you understand how to tell the difference between those because there's a whole part on the homework quiz that's going to be on that. And we're going to talk about phase changes. And that's it. We're going to do some definitions. All right. So let me see. I'm going to set this up here. All right. I'm going to turn this way. I'm going to join the audio here. Unmute. Turn this up. Connect the audio here. Sorry, give me 1 second, guys. you guys hear me? Sam, I can see you, so can you hear me?
Yes, ma'am.
Okay. And then you guys know, there's no feedback.
Miss Peyton, I have a real quick question.
Okay.
So to turn in the video, can I just send it to you on Remind? Because I did it on paper.
Oh, yeah. The video notes, you don't have to, that's fine as long as you have them. That's fine.
Okay.
Let's see. All right, so I'm gonna try to, let's see if I can make myself the host. So because I'm going to be at this other board, guys, and I'm not gonna be near the chat, I really need you guys to just kind of unmute if you have a question, okay? Or if I'm going too slow or whatever the case may be. So we're gonna do some notes today. I'm gonna see if I can share my screen. Let's see how that looks. Perfect. All right. All right, so I'm gonna try this just so I can see it. Okay. All right. All right, so can you guys hear me okay? Sam, I can see you, so you can just nod your head if you can. Yes, okay. All right, so a couple of things. So first and foremost, we were talking about there's two different types of properties. Okay, two different types of properties. One was the physical properties. Sorry, that looks really sloppy. This is my first time writing on this board. Okay, so one was physical properties. All right, and then the other one was chemical properties. All right, so physical properties are going to be, I'll do this. Oops. All right, so physical properties are going to be properties that, trying to get this slide out of the way. We'll figure it out, okay. Physical properties are gonna be properties that you basically are using your five senses to discover. Like, does it feel a certain way? Like, is it hard? Is it soft? Is it rough? Is it smooth? Or something you see, right? It's shiny, it's red, it's dry, well, dry, we could kind of feel that too. It's purple, okay? So those are physical properties. So physical properties are going to be the ones that you kind of use your five senses to determine. I write much better on the real board, so bear with me today. All right. When you're looking at a physical property, there's nothing about the substance that you have to change, okay? So for example, physical properties of this. It is red, okay? It's square. It is thin, right? It's thin or thicker if you look at the whole thing, okay? It is light. So those are physical properties. I don't have to do anything to this. Nothing about this has changed, okay? So those are physical properties. I use my five senses. It's light in terms of the mass. I could weigh it, okay? I can see how much space it takes up. Those are all physical properties. When we're talking about chemical properties, however, okay, if you're talking about chemical properties, you basically have to do an experiment or you have to change something about it, okay? So something has to change about it. Usually, something will change about it. Oops. And when I say change, I don't just mean, for instance, let's see. All right, so if I have a sheet of paper okay, and I ball it up, I changed something about it, but it's still a sheet of paper. I can look at this and see it's still a sheet of paper. Even if I rip it, okay, I changed something about it, but it's still paper, okay? When I say chemical properties, a lot of times it ends in the word ability, not always, but a lot of times it does. So for instance, let's do a couple of definitions. How about like, so yesterday they talked about two of them, two different chemical properties. One was combustibility. I'm going to try to write very neat. Combustibility. Okay. And one was flammability. Ooh, let me try that again. All right. Okay. Oh, I'm not on draw. Sorry. All right, just broke my board. Let me see if I can do this here. I guess I have an unclick eraser. Text, draw, this. There we go. Flammability. Flammability. There we go. All right. So for instance, where is, I need a highlighter. No highlighter, spotlight. Let's try this. Notice the word ability right here, okay? So like the ability to do something. Combustibility, it is the ability to burn, okay? Ability to burn. So this, when you have combustibility, this is stuff that will, will burn, okay? This is stuff that will burn, okay? A piece of paper is combustible, it will burn. Trees are combustible, they will burn. Wood, a lot of stuff is combustible. And when we say burn, it will burn pretty easily. If I put a match next to it and it catches on fire, that's combustible, okay? Now, flammable is like super, it will easily ignite, like gasoline, okay? Gasoline is gonna cause an explosion, okay? So that's the difference between the two. So this one will, make sure, easily ignite and burn, okay? Will easily ignite and it will burn. Right. So I gave you two examples for chemical properties. These are, we're talking about properties right now. Can somebody give me a physical property, any type of physical property? You have to unmute and tell me.
Crushing.
Say it again. I just didn't hear you.
Crushing.
Crushing. Yes. So yes. So technically, actually, you're a little bit ahead of us. That's a physical change. Yes. Okay. So it's a physical change. What about, what can you just use your five senses to do, to observe? We're going to get to the changes later.
Texture.
Density.
Density, for sure. I heard somebody else say something else. What else?
Color.
Color. Yep.
Texture.
Texture. Yep. Let's do one more. How about, I'll give you three. Shape. Volume. What's all matter made of? Volume and, starts with the M.
Mass.
Mass. Okay. All those are physical properties. Very good. Okay. All right. So today we're just talking about just the properties, but eventually we're going to go to physical and chemical changes. Okay. So it's kind of the same thing, except for now you're actually doing something. Like Sam said, crushing, tearing, flattening, those would be physical changes. Chemical changes would be, okay, so it's combustible, then I'm going to burn it. I'm going to ignite it. It's going to combust, okay? But today, these are just These are just properties, okay? So this is properties. All right. Do you think you could be able to tell me the difference between which ones are physical properties and which ones are chemical properties? Okay, did you guys tell me the difference between those? Just if I ask you just in general, because that's what you have to do.
Ms. Payne, I can't really hear you good. You sound muffled.
Sorry. Can you hear me now?
Yeah, you good.
Okay, let me slide this table this way. I need some books. Let's see. Set my laptop on. All right, let's try this. I keep coming back over so I can see you guys. There we go. All right. Now you can see me and you can hear me. Yes?
Yes.
Yes. Okay, good. All right, so now we've talked about this. Does anybody need me to leave this up? Because I'm about to erase it. So if you need me to leave it up, just unmute and say I'm still writing or something. Okay. All right. So now let's talk about phase changes or the 3 states of matter, the 3 phases of matter. All right. Alexa, can you tell me one state of matter?
Solid.
Solid. Very nice. Solid. And then, Kai, can you give me another one?
Liquid.
Liquid.
Very nice. And somebody give me the last one.
Gas.
Gas. Very nice. All right. So we did talk about yesterday, there's actually these other little small states, but we're not going to talk about those because remember we were like, what's food pudding and what's jello and all that stuff. We're not going to talk about those. And we also know, some of us said that there's also, there's also plasma, but we're not going to worry about that one right now. We'll talk about that one later. All right, so let's make sure we understand the difference between the 3 of these. All right, so I have, tell me who has, so let's do it this way. I'm going to say, all right, in terms of, let me undo. So let's talk about, all of them have something to do with shape, something with volume, and then we're going to talk about their particles. Oof, that is rough. All right, let me try writing that again. P-A-R-T-I-C-L-E-S, particles, which we know the particles are called, what? They start with the A. Those tiny things that make up everything. Atoms. Very nice. Atoms. All right. So for a solid, is the shape defined or can it change?
Defined.
It is defined. Very nice. All right. So for a solid, it is defined. Okay. So that just means it cannot change. How about for a liquid? Can it change? Yes or no?
Yeah.
No.
Can a shape for a liquid change? Cam, can the shape for a liquid change? If I take the cleaner in this bottle and I pour it into something else, will the shape of this liquid change? Cam?
Yes, it's an indefinite shape.
Yes, it is an indefinite shape. Okay, so this is indefinite because this one, I have to make sure I pick up my hand in between my letters. Indefinite. So it takes shape of container. Okay. So if I have a bottle of Sprite and I pour it into a glass, my Sprite is now in a different shape, right? Take shape of container. How about gas? Is it defined or indefinite?
Indefinite.
It is also indefinite. It will also take the shape of its container. Okay, so same. Okay, all right. So if I could take all the air in this classroom and compress it, right? That's exactly what they do when they make soft drinks, right? When they have sodas, if you have a Coke or Sprite, when you open it, what sound does it make? Right? That's the air escaping. They've taken all this air and they have compressed it, okay? They've compressed it into a gas. That's what those bubbles are also when you see your drinks. All right, volume for a solid. This is also going to be defined. I cannot take my mouse, okay, and squish it down and make it smaller. I cannot. However much space is taken up, that's how much space is taken up. I can't make this any smaller. Shape is defined and the volume is defined, okay? Liquid, if I have a 20-ounce bottle of Sprite and I try to pour it into a 10-ounce glass, it's going to run over because the volume is not going to change. So the volume for liquid is also defined, okay? All right. Jasmine, how about a gas? Do you think the gas is defined in terms of volume? Brandon, what do you think? Do you think the gas is defined? Do you think it's undefined or defined?
Indefined.
It is indefined, okay? So undefined or indefinite, okay? So I'm gonna write it as undefined. Now, undefined and indefinite mean the same thing. So let me finish writing it first. Okay, so this one, oops, I did not mean to do that. So this indefinite, okay, and undefined mean the same thing, okay? It just means it can change, right? So if you're thinking about it, right, if I take a balloon and I blow air into it, okay, it's going to take up, the volume can change, it's going to change based off of how big the container is. All right, so now let's talk about the particles, okay? If we're looking at the particles for these, let's just pretend we had some little containers here, okay? All right, so I got a container for my solid, a container for my liquid, and a container for my gas. All right, so if I'm looking at this same amount of space, okay, in a solid, what color do I want to use? Use green, all right? In a solid, okay, all of the atoms are going to be right here packed together. Oops, I picked up my hand. So everything is going to be right here packed together. So I'm drawing them with a little bit of space because otherwise it looks like a little line, but really there's no space in between them, okay? They're just sitting right there. They're really touching each other, okay? And that's exactly why when you have a solid, the shape doesn't change. Everybody's up on each other, okay? All those atoms, they're right here, right next to each other. There's nowhere to move. They actually are moving. They just kind of vibrate in place though. So they're just sitting there and just going like this. This is as far as they can move, okay? This is all they're doing. Just sitting there, that's as far as they can move. So they vibrate in place. So even when you look at a table, obviously it doesn't look like a table is moving. The little atoms in there, they're moving, but just it's so little that they're moving that you can't see anything, all right? So a liquid, there's a little bit more space in between them, all right? So if I got a liquid here, it's a little bit more space, all right? And that is the reason why when you pour a liquid, those particles tend to flow or slide or, I'm trying to think of another word, glide past one another, okay? They flow or slide or glide class one another. Okay. All right. Gases, particles far apart or close together?
Far apart.
They are very far apart, okay? So even if it's the same number of particles, okay, they're really far apart because they want to fill up their container, okay? They want to fill up whatever container they're in. So they're very far apart, okay? So very far apart. Very far apart. But here's the cool thing about a gas though, okay? Let's think about this. You ever seen like the cans, it may be a can of cleaner or a can of like air freshener or whatever. Anybody know what the warning says on the back of those cans?
No.
Nobody knows what the warning on the back of a air freshener can says? What are you not supposed to do with it? Or what's it not supposed to do?
Pierce it.
Yeah, you should pierce it. That's one. And then something else you need to keep it away from.
Fire.
Fire, right? All right, so this is why, okay? If I have a can, now remember, particles in a gas like to be very far apart, okay? If I want to take all those particles and put them in a little can, okay, which we call compressing, okay? I can take all of those little particles, squeeze them in a can. So they're already way closer than they want to be, okay? So if you pierce it, those particles are going to go like this, and something's going to blow into your eye, okay? If you get it near fire, do you think those particles start to move slower or faster? If you heat up, would you move faster or slower? What do you think?
Oh, it's gonna go faster.
They move faster, okay? And if they're in this can, those particles start moving fast, and they're hitting the sides of that can. What's that can gonna eventually do when it gets too hot? It's gonna explode, okay? So that's why. So with a gas, it's kind of cool. You can compress or expand the particles, okay? So that's what a lot of those cans have. They have gas particles in there, compressed in there, okay? When you buy, if you've ever seen compressed air, the ones that you can like spray off your desk, like clean stuff with, it's a bunch of compressed air. That's exactly what it is. It's gas particles that are compressed down. I was talking about the sodas, right? They put air in there, it's carbonated, okay? Which is CO2, which is a gas, carbon dioxide, stuff we breathe out. They put in a gas in a can or a bottle, okay? So as soon as you open it, those gases particles are like, whoo, I'm out of here, I'm free, right? They escape. That's the sound you hear when you open your soda or when you pop the top. That's all the gas particles going out. All right, so the big thing to know for these, okay? Solid, defined, and defined in terms of shape and a volume. Particles are very close together. Let's make a note of that. These particles are very close together, very close. Sorry, that's so messy. Together, all right, and they vibrate in place. All right, liquid is the only one that's like half and half. So solid, both defined, gas, both undefined. Solid, liquid is the only one that's like half and half. So the shape can change, but the volume does not, okay? The particles have a little bit more room in between them, okay? And they flow or slide or glide past one another. That's why liquids, like think about running water, right? Okay. Gas, undefined and undefined. Remember these two, indefinite and undefined mean the same thing, just means they can change, okay? You can compress it or expand it. That's a really big, important thing, all right? And then, I heard somebody come in, but I don't see it. all right? And then the particles are very far apart, okay? Can I erase this? Anybody still writing? Okay. All right, we're gonna get the phase changes. Good. All right. Let me see what your notes are about. Let's see. If you got your notes out or up, let's talk about those just for a second. That'll be how we end. Let's see. All right, so then we went into physical and chemical changes. All right, so I'm going to clear all drawings. All right, so then we talked about physical and chemical changes. All right, so that's kind of what we had started talking about before. So we had physical. There we go. Physical. This time we're talking about changes. Okay, so this time we're talking about changes. And chemical changes. We're not going to focus on chemical changes today. Today we're just going to work on physical. Okay, just physical changes. All right. So these are things that you can do to something and it doesn't change what it is. So you're not just making an observation, you're actually doing something. Okay. So we can say do something to the substance. Substance just means a thing. That's what we call stuff in science, substances. Do something to the substance. But, this is really important, but it does not change what it is. Okay, so this is the important thing we were talking about before. Okay, so we're not going to worry about, we're going to talk about chemical later, so don't worry about that one. Okay, so physical changes. All right, so earlier Sam gave me an example of a physical change. So let's just see how fast we can kind of go through these. All right, so earlier Sam said an example was, he said an example was, crushing. All right, if I take a rock and I crush it into smaller pieces, it's still a rock. Okay, somebody give me another example. Isaac, can you give me an example of a physical change? What can I do to
A physical change?
tell me what I can do to this piece of paper and it would still be a piece of paper, but it would not look like this.
You could crumble it up and then flatten it back out, I guess.
Yes, I could crumble it. Yep, so we could crumble something.
Or I guess you could cut it, couldn't you? Could you do
I
that?
sure could. I could cut or tear it.
Or fold, I guess.
Or fold, yep. Okay, crushing, tearing, folding, crumbling, ripping. Let's see, what else could I do? All those are physical changes. I could even take this and change the color of it, right? It's still, well, let's not do that one. Let's not do that one. It's still paper, but let's hold off on the color change. All right. So those are physical changes. Now we're going to talk about the physical changes that people don't look like physical changes. And these are phase changes. Okay. Now, any of your phase changes are physical. Let me tell you how you remember that. Okay. Phase changes are physical changes. Okay. Phase changes are physical changes. It's going to look like you changed it into something else, but it is still the same substance. For instance, okay, if I take ice and it melts, what is ice made out of?
Water,
And if it melts, what is it?
a liquid,
What type of liquid? What's the name of the liquid? What's melted ice?
Water.
It's still water, right? It's the same thing. That's a phase change, right? I melted it, okay? I can either go the other way. I could take liquid water, store it in the freezer, is now frozen, it's ice, it's still water, right? It's the same thing. Phase changes are physical changes, okay? So this is the hardest thing because sometimes people say, oh, well, it looks different. Yeah, it looks different, but it's made of the same stuff, okay? And I'll tell you just as a heads up, like I said, the difference is like if you think about if I take a piece of paper and I burn it, do you get new stuff? What happens when you burn a piece of paper? What do you get? Tell me something you see.
Isn't that chemical?
It
If
is,
you
and I'm
burn?
asking, I want you to see the difference. So for instance, if I burn a sheet of paper, Kanye, if I burn a sheet of paper, tell me one thing that you would see.
The
Ashes.
paper would get darker and you just see it like go away, slowly go away.
So Sam said it would get darker. Muhammad said you would see ashes. Ashes is a new thing, okay? What else would you see? For me to burn it, what do I need?
You could use a lighter or a match or gasoline.
Something that's gonna give me fire, right? Okay, so great. All right, so let's talk about, let's just try to get these phase changes down really quickly and then we'll be done for the day. I'm gonna erase this unless someone's still writing. I don't think anyone is. All right, I wonder if I can slide this actually. Oh, give me a new page. All right, so here are your phase changes. Let's see. Gabby, can you give me one phase change, you know? So we can think about water if you guys want. Gabby, you got one phase change for me?
What was the question?
Can you give me a phase change? Tell me what happens if if water goes from a liquid to a solid, what did you do?
From a liquid to a solid?
Yeah, how do I change water from a liquid to a solid?
Oh, you can freeze it?
Freeze it. Okay, so freezing is a phase change. That's one phase change. Anybody know the opposite of freezing something?
Melting.
Yep, melting is one. All right. Anybody know what it's called when the side of your glass is wet? You know how, isn't it weird? Like you just have a glass, it's got ice in it, it's cold drink, but somehow water gets on the outside of it. Anybody know what that's called? It starts with a C.
Condensation?
Very nice, condensation. What happens if you put water in a pot and you forget? Is the water gonna be there the whole time?
Isn't it gonna start evaporating?
Very nice. Evaporation, that's another one. Thank you. All right, and then the last two can be kind of hard. All right, so one is called sublimation. Let me write that again so you can see it. S-U-B-L-I-M-A-T-I-O-N. And the other one is called deposition. D-E-P-O-S-I-T-I-O-N. All right. So on this one, so these are phase changes. We know we said we had 3 phases. We said we had solid, liquid, and gas. All right. Charles, if I'm freezing, can you tell me which one am I starting at and which one am I going to? I'm gonna make you guys start turning your cameras on. Come on, come on. Kaya, can you tell me if I'm going, what am I going to if I'm freezing? From what to what?
Um,
Freezing. What phase, so which one of these am I starting at? And which one am I going to if I'm freezing?
Liquid to solid.
Thank you. It's from a liquid to a solid. All right. So this one is liquid to solid. All right. The quicker we participate, the quicker we finish. Can anybody give me what melting is? From what to what?
From a solid to a liquid.
Solid to a liquid. Anybody want to take a guess on condensation? I'll tell you that remember you get that liquid on the side of your glass. Where do you think you started?
Oh, from a gas to liquid.
Very nice. And remember I said, these are opposites. These are opposites. These are opposites. Josh, how about evaporation from what to what?
It's gonna be a liquid to a gas for evaporation.
Very nice. All right. Sublimation. It's kind of weird. I'll show you an example next week. Solid to a gas. And deposition is from a gas to a solid. And you can do these. All right, get these down. Next week, we will have a little homework quiz. Any questions? All right. Toodaloo. Make sure you get your last of your notes before you leave. Okay, I got you. Thank you.